In this video I'm going to show you how I made this probe in order to easily find the X and the Y 0, also the Z 0, but for that I already had a probe. I'm going to model it, make the Gcode, go to the CNC and mill it, and you will see along the way that I made some mistakes and I'm going to tell you how to fix them, how to make everything work as it should. In the end, I'm going to show you how to set up Universal Gcode Sender and how to use the probe module in order to easily find the origin whenever you have a workpiece that is not in the origin of the machine. So let's get started, but before moving on, I want to thank everybody that support me, being on my YouTube channel or on my Patreon page. Every subscription helps me a lot to keep doing what I'm doing. Thank you all. Now let's get started. Let's make this probe. For this little project, because it's a simple project, I'm using FreeCAD 1.0. You can use any other design software if you want, but if you want to use FreeCAD, let me show you how I designed this probe. I will start in the part design workbench. I will create a new body. Let's go to the model tree and press F2 to rename it probe. Create a new sketch in the XY plane. And in this sketch I will define the overall shape of the probe, which is going to be a rectangle 60 mm by 60 mm. As you can see, setting the dimensions in FreeCAD 1.0, it's much easier than in the previous versions. The sketch is already fully constrained. I can close it and make a pad of 12 mm. You might ask why 12 mm? That is because 12 mm is the thickness of the aluminum plate that I had around. That's what I'm going to use, so if you are using a different thickness, don't forget to modify the length of the pad. Now I can close the pad, and after selecting the top surface, I will create a new sketch. Using the external geometry tool, I will select the top line and then make a new rectangle starting from here, and now I'm going to make it 40 by 40 millimeters. The sketch is fully constrained. I can close it and make a pocket using this sketch, and I'm going to mill half of the total thickness to have 6 mm for the probe. What I don't like about this rectangle is this corner, which will result in a round over here because of the Toolbit, and I want to have a notch here in order to be able to correctly fit it on the material. For that I'm going to edit the sketch a little. Let's zoom in, and I will create a circle close to this corner but not exactly in the corner, and I will give it a diameter of 12 mm. Why 12 mm? Because the toolbit that I'm going to use is a 6 mm toolbit, and I want it to easily enter in this little notch to avoid any kickback, any damage to the toolbit. Using double the diameter will make sure everything is okay. Of course, this kind of sketch with overlapping lines is going to throw an error, so I'm going to select the trim tool and remove these 3 lines. Now I want to position the circle, and for that I'm going to create a new line between these 2 points. Right click and select the line again, turn it into construction geometry. This means that this line is not going to be taken into account when making pockets or pads. And select the line, the center of the circle, press KD to set a distance, a free distance, and I'm going to use a 2 mm distance. After that, as you can see, I still have 1 degree of freedom in the solver messages box, which is this movement. I want to make it fixed. For that I will select this line and this line, press E to set an equal constraint. Now, since these 2 lines are equal, everything is perfectly determined. Closing the sketch will reveal the new pocket, because as you remember, I've edited the sketch in the pocket already created. I still need to do one thing, which is a hole here, a hole for an M5 screw. I'm going to make the hole a little bit smaller, of course. The diameter of the hole for the M5 screw is 4.2 mm. So let's create a new sketch. Create a circle of 4.5 mm. I'm going to use a slightly larger diameter because the toolbit will have a little bit of deflection. I want to make sure I won't damage the tapping tool, so I'm going to use a slightly larger diameter. I will select the center of the circle, place it in the center, so 10 mm, and distance on the vertical of 50 mm. Close the sketch, make a pocket. This time I'm going to use the through all type. Now the probe is ready, I have everything that I wanted to have, and we are going to the CAM workbench. I'm going to select the object, create a new job, click on the OK button. In the setup tab I won't change anything because I've modeled it starting from the origin and the origin is correctly placed for the machine. I don't want to change anything. Let's go to the tools menu, click on the add button to add a toolbit. I'm going to use the 3.175 for the hole and add a second toolbit, the 6mm end mill for milling the pocket and the outline of the probe. Now let's give them some speeds. Since I'm milling aluminum and I will use a step down of 1mm, I'm going to use smaller speeds for the 1/8 of an inch toolbit and the spindle of 19,000, and for the 6mm end mill I'm going to use a slightly larger speed. The same spindle speed, and I will remove the default tool. It is useless here. It was there just to be able to create the job because it needs to have a toolbit. I will click on OK to close the job, and now let's start creating the operations. First I will select this wall and the Helix tool. It will ask me which tool controller to use. I'm going to use the smaller toolbit. Click on the OK button. Let's go to the depth tab because the default step down is the tool diameter. I don't want that, but I cannot edit the value by simply clicking here, so I will have to edit the expression. I will click on the clear button. Now I can edit this value. I'll write 1 for a 1mm step down. In the operation tab I don't have to change anything because it's a very small hole, so just click apply, make sure the toolpath is OK, click on the OK button to close this operation. You can see it here in the list. Now let's create the pocket for this cutout. Select the surface, click on the pocket button. The first thing that I want to do to remember is to change the tool controller. The default tool controller is the one used for the previous operation, which is the smaller one. I'm going to select the 6mm end mill and click on apply to see what happens. As you can see, it's a horror toolpath, and that is because of a few things. First, the pattern, change it from zigzag to zigzag offset. And I want to change the angle to from 45 degrees to 0 degrees, which means along the x-axis. I'm doing that because my machine is much more solid on the x-axis and I want to use that axis as much as possible. If I rotate the view, I can see that I only have one pass, which is absolutely too much for milling aluminum, or at least on my machine. So let's go to the depth tab and change the step down. Since it's a 6mm end mill, the default step down is the 6mm. I want to change it into 1mm, but I cannot click here and edit because it's based on an expression. So I have to click this little blue circle, click on clear to remove the expression, and now I can write a step down of 1mm, click on apply again, and as you can see, I have several layers. One last thing that I had to think about in the operation tab was the step over. The default 100% removes as much material as possible, and I thought, well, it's just about material removal, so I can leave it like that and everything will work okay. But here comes the first mistake that I made. Using a 100% step over, and because the toolbit still had a very small deflection, left some very thin shims in the center. I could have removed them using a file, but I think it's much better to have a flat surface from the CNC. So I went back to FreeCAD, changed the step over from 100 to 80%. The last operation that I want to make to create in FreeCAD is the cutout, the profiling. But there's one little thing that I missed when creating the pocket. I was very nervous because it was the first time that I was going to use only air cooling. Until now I used some hand spray with a cutting oil, and I had this small improvement to my CNC, the compressed air nozzle, and I wanted to see how it works in aluminum without any liquid, just with air. Because I was thinking about that, I forgot something. Let me show you from a top view, and you can also see on the piece here. The corners had small roundovers. In my situation, because I realized that just after milling the piece and removing it from the table, I use the file and I remove that material. I don't suggest that. And let's fix this in the pocket shape operation. So open the operation, go to the extensions tab, check the enable extensions and check the face that is here. You can click on it and see its outline. Now if I click apply, you can see the toolbit is going to go all the way to the corner of the material. This will result in a perfectly flat edge both here and here. So now I can close the pocket shape operation and proceed to the last one. I don't need to select anything for the last operation because it will default mill the entire outline of the object that is in the job. So click on the profile button, go to the depth tab to change the step down. This time the toolbit that defaulted in the operation is a 6 mm because for the last operation, the pocket, I already used this. You need to make sure each time you set a new operation, use the proper tool controller, double check it in order to avoid mistakes. Now let's go to the depth tab and again change the formula for the step down. Click on clear to remove it, or I could simply divide the tool diameter by the tool diameter itself, and this will always result in a step down of 1 mm. It doesn't really matter, you just have to have a step down of 1 mm. After clicking apply, let's double check the toolpath, everything is okay. Click on the OK button, but I need to fix something because this piece is going to fly away. I need to add some holding tags. In order to create the holding tags, I first have to select the operation, go to the CAM menu, path dress up and select tag from here. The default number of tags is 4. I can see them placed around, but I only want to place them on these two edges because these two edges need to be really flat. Creating tags there and removing them using sandpaper or a file probably won't result in a flat surface, and I don't want that. So let's move 2 of them. I will select it from the list. Let's see which one I want to move. This one, click on the edit button and place it somewhere around here. It doesn't matter which layer you are selecting. Now let's find out which one is this. Number 2. Click on the edit button and place it somewhere around here. But I also want to move these two a little bit. So the top one is number 3. Click on edit and select a point a little bit to the side. Now let's do the same for the first one, which is in the middle. Click on edit, move it. Now if I click on apply, you can see the tags have moved. What I still want to change is their shape. I'm going to use a width of 10 mm, a height of 2 and an angle of 90 degrees. But what if your machine has some problems with the plunging? Well, you could change the angle to 60 degrees and this will result in a ramp entry sort of plunging. So after clicking on apply and making sure everything is okay, I can close the operation. Now that everything is ready, I have to export the job, go to Universal Gcode Sender, go to the workshop and mill the actual piece out of aluminum. Since I'm using 2 toolbits and I don't have an automatical tool changer for the machine, let's go to the job again, go to the output, change order by from fixture to tool, check the split output, and now I can close the job. After the job recalculates, I have to select it, click on the post processor, and I will have 2 Gcodes, one for the smaller toolbit and one for the larger toolbit. Now let's go to the CNC and make this plate, make this probe, and I will also show you how to use it in Universal Gcode Sender. The first thing that I want to do is to move the tool bit closer to the position that I want to find. I'm going to move it pretty close to the X, Y, and Z of the corner of the board. I will set the probe's movement range to be in a 1.5 centimeters from the corner of the board. I think it's enough. I can visually place it in that area, place the probe, and then run the script to find the exact corner of this piece. Let's move it a little bit to the right and a little bit backwards. Now I'm going to place the probe in the corner of the workpiece. You can see that I have this cutout here, just as I told you. If I didn't create this notch here, the corner would be round and that would prevent the probe going to the exact corner. Raise the Z a little bit, place the probe as in the corner as possible. Well, I also have to take care for the cables, and I will connect the clip to the tool bit, and I will also fit the cable around some piece of the spindle in order to avoid it being dragged out of the table. So the probe is where it should be. Now let's go to the universal Gcode sender and set up the routine. As you can see, my X, Y and Z are some random values. I will go to Window, Plugins, and here I have the probe module, where I already have the settings that I have defined, but I'm going to explain them one after the other. Sometimes you might end up with this very nice view of what the probe is going to do. Sometimes you won't if you don't go to console and back to probe module. A visualization of what will happen will show on your screen. Now I have these values. First I'm in the XYZ probing because I want to set all the three axes. I have a probe distance of 35 millimeters. Why is that? Because my probe is 20 millimeters away from the workpiece, as you remember from the design stage, and I want it to move 15 millimeters outside. That's why I was telling you I can set the tool bit up to 15 millimeters to the inside on X and Y. Otherwise, when moving to the outside and going down, it will hit the probe. So make sure this distance is at least equal to where the tool bit is on the workpiece. I think a 15 millimeters should be fine. Setting them both on X and on Y. I also need to set the offset on XY, which is 20 millimeters. Again, as you remember from the design stage. I will set the distance on the Z-axis of minus 15 millimeters. This is the total distance. It will lower the tool bit. Make sure to set the distance smaller than the distance from the tip of the tool bit to the table, because otherwise it will plunge into the table and you don't want that. At the bottom we have the offsets on X and Y and the thickness of the plate, which is the thickness on the smaller part where it touches the material. After setting everything, I can click on this button. Just for safety reasons, I will also hold my hand over the stop button of the power off button. Let's click this button and see what happens. But I stopped the routine because I forgot to show you the other panel for settings, which is essential for what we are doing. The settings here, where I can set the tool bit diameter. If I don't set the tool bit diameter correctly, the X and Y won't be the correct ones. The Z will be correct, but X and Y won't be the correct ones. And the most important settings, the fast find rate and the slow measure rate. In my situation, I think 100 with 50 are okay. If you set too high values, the machine won't be able to stop when touching the probe, and you will end up with some damage either to the tool bit or to the probe or to the machine itself. So make sure you use small enough values at first, then maybe increase them if you find that your machine can handle it. The retract amount, of course, is the distance to retract between the two cycles, between the fast cycle, the fast find, and the slow find. And the work coordinates, this time I'm going to use G54, but if you have several work coordinates, several fixtures on the table, you can set the 0 for each of them. then you can run the program with various work coordinates. I'm going to leave it to G54, so let's go back to XYZ and start the probing again. As you can see, there at first is a faster movement and the second movement is slower. The X and the Y motors make much more noise than the Z motor because they are different drivers. And now the machine moves, after finishing this cycle, the machine moves exactly where it started. As you can see, my coordinates are not correctly set. They are 0 on each of the axes, which is not true. I believe this is a bug. Running the script again. So it goes back to 0 and then resets all the values to the correct ones calculated based on the probing. One more thing you need to know before proceeding to making the actual work is go to console, and as you can see here it entered G91 mode, which is incremental mode. Let me show you what happens. I will remove the probe now, I don't need it anymore. If I write here G0x0, it does nothing because the G91 here, I don't know why it tells me here it's in G90 mode, because I can see the last command here, so it's a bug from Universal Gcode Sender. G91 means incremental mode. G0x0 means move 0 millimeters on the x-axis, and that's exactly what it does. In order to go back to G90, I will simply write G90 in the console, press enter, and now if I press G0x0, you can see the machine moving to the origin on the x-axis. Now let's move it on the y-axis and finally on the z-axis. As you can see, the center of the toolbit is exactly in the corner of the material. So this is my simple build, my simple probe. Thank you for watching. See you next time with another video about using open source software to generate Gcode and, as you've seen in this video, to make useful stuff on the CNC.